Alright, welcome to Minecraft Circuits in Real Life. Previous session we took a look at the breadboard and how we wire up an LED and how energy is routed through a closed loop in a circuit. So what we have to remember to continuously do is make sure that our circuits completely touch. And so like as I'm wobbling this, sometimes it disconnects a little bit, and as I take it out, it goes off and on. So anyway, what we'll see is the nature of these circuits is that we only do they work when you have everything connected all the way through. And so in Minecraft, that's actually like the redstone. Everything has to touch for it to be connected. So in real life, everything has to touch, but they have to sort of, in the breadboard case, we need to make sure they overlap one row to the next row so that one input goes to the next one. And we'll explore that a little bit further, but what we want to introduce now that is the idea of the button and the lever, or the pressure plate. So let's start. We've got the ability to wire up our LED and make sure that it's safe, and will work for us through the rest of the projects. So if I touch this, what I'm doing is I'm opening the circuit, I'm closing the circuit. And this is exactly the same thing that happens with levers. This happens with pressure plates, this happens with buttons, that when I close the circuit it's on, when I take it off, it's off. So basically with the closed circuit we've got our light, with the open circuit, or the disconnected circuit, it's off. So what we want to do is work on this a little bit. We're going to rewire it. I'm going to set it up for our button. So I'm going to pull this off and we'll start from scratch. I've got a button over here. So again, if I take the top of the button off, you'll see you got to be careful, the ends here will poke you. But they're very friendly to the breadboard. So if you wanted to, you can take a Lego piece and just jam that on there. But for now, we're just going to take our button caps and we'll make sure those caps are on. And as you do this, you can hear a click. So now that click is there, you press that a bunch, and basically it's opening and closing. And the structure for this button is I've got basically two wires. It looks like 4 points. But what happens is I have the point in one part, and in the chip itself, or in the package itself, it has a wire that goes through, and that's this one to this one. And the second one has the external point and has a wire that goes through like this. And so what happens is these two loops have to be connected for the circuit to work. So when I press down, it's actually basically lowering a connector into the space, and when it does, it crosses these particular things. So you could think of it as a piston with a redstone block on it connecting the two things together. So there's kind of like, in Minecraft it means that you've got it open, you've got it closed, but it would be two redstone wires that might be separated by a block, and then once you've connected it with a block temporarily, like a redstone in the middle, it would connect it through. So that's our button. So the idea is it's going to be disconnected in its natural position and then connected when it's pressed down. And we got to route this through our circuit. So we have to, basically we have the battery that has the minus and the plus end. But what we've got for this is that we're going to use the battery in the sense that I've got a black wire, and that's going to be the negative, and I have a red wire, and we're going to make sure the red wire is going to be our positive. And so wherein this connects through, that's going to be our circuit. So in this case, I'm going to, let's see which way. You can decide which way you want to wire the circuits, but in this case I'm going to actually, let's put the positive on the right all the way down to this end, and I'm going to put the negative on the left. So all of our circuit is going to do is it's going to go in the middle. So what I need to have happen here is I need this particular edge to touch onto the ground side. And in fact, these things fit really nicely, so if I push them on top of the breadboard, I can actually get them to hook right in and press down, and they stay on their flat. And once they've stayed on their flat, we're in really good shape. You see the breadboard's holding everything in place and not letting it move. And then I have my little wire connected here to here. So we're good on that side. So the next thing is that for for our LED, let's put the resistor in place. And what I'm trying to do is I'm actually using the wires, the leads of the resistor as part of my wire. So right now I have the wire coming in to the button, and then I have the wire coming out of the button, and I'm jumping over to a random row outside. But what I need to do now is this random row needs to connect to my LED. Now remember, you can put this in one of two ways. One way it won't turn on no matter what you do, and the other way it will. So the long end for this one is positive, and the short end is negative. Now you typically you'll find a flat side to the to an LED, and wherever you find that flat side is the negative. But occasionally they don't have those. Additionally, sometimes you get them clipped and you can't tell. So what'll happen is you'll put something in and you don't know the direction. So I'm going to wire it correctly first, and then I'm going to wire it incorrectly second. So what's going on here is I'm going to say, okay, this is the negative side, this is the positive side, so I want the short wire to go over. So here's the short wire and that. So I'm going to put them in two different rows. And so when I have them in two different rows, now this row touches the negative here. So the negative goes through, there's the button. If it was pressed, it would touch the resistor touches this side, goes up and through. Then we have our output. Now, we could do this in two ways. I can just take my wire and put my positive lead here. So we're gonna demo just moving it so that I have a small circuit, and we're using the minimum set necessarily in order to make this LED go on and off. So now I press the button, off and on, boom, 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 really, really fast. I mean, this is mechanical stuff here. It's about as fast as humans can go. You can just press it as many times you want. And this is exactly like the button in Minecraft. It's temporary, boom, boom, boom. Now it'll stay on as long as you hold it and you let it go. Now it's disconnected, the energy is not flowing through. Now you can have the scenario where I just pull that out and I can still tap the wire. So I'm holding the circuit closed. So there are situations where something may be disconnected and you're trying to figure out what's going on. But what we're really wanting to explore is that with this LED, I put it in the correct direction. So if I flip it around, I put the positive on the negative end and the negative on the positive end, we're not going to really damage anything, but what we're going to do is we're not going to have anything work. You're going to press this button, no matter what, nothing's going to happen. So basically you could get really frustrated, but by taking the LED, double checking it and flipping it around, making sure everything's connected, you're back in action. Now, one of the things that I can do too is I can say I want to have my power way over here, and if I want to move the circuit so that the power goes from one place to another, this is where I would use a wire. So I just grab a wire, and I can take the output of the LED and I can move that over to my battery, and now when I press this, bang, 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 it's off and on, off and on. So I've just routed power in different ways, but you can take this and you can make this loop as big as you want, take lots of other wires, so I can actually jump this to another part of the board. You can tell it turns off, and I have to remember to test it by actually pressing the button. But I can loop these wires around and make a crazy rat's nest of madness. And so that sort of thing is you can make stuff really complicated, but that you can also make things like basically super efficient. So one level of efficiency is just have one wire that does that, and another level of efficiency is to just actually use all the properties of your parts, hook them together, and then once you have them, they all fire right up. So I would say that's our button with off and on and how we fire up the LED. So thank you for running through this section with me, and we're going to work on a couple of other options next. I think like the levers, and we're going to then, after going through levers, we'll do jumping into series and in parallel with our button. Alright, thank you!